I want to do this short video on the method of least squares as described in our handout on experiment 1. And I wanted to do this video just so that I can kind of step through. And if you didn't catch this in the pre-lab lecture, you can come back and review it here. So that's really the purpose of this video. Now, you'll know from our discussion in lab that if you have a set of data points, as shown here, you can plot those data points on a graph, and using a method known as linear least squares, you can actually calculate the best fit line. And what you're really doing is you're calculating the parameters for this line using this method. And now, what are the parameters? Well, the equation for the line is given here, and we are usually see it as in the symbolic form as y is equal to m times x plus b, where m is the slope, and this would be our 1.879, and where b is the y-intercept, to the point at which this line will intersect the y-axis down here, and that's given here and for this particular example as 0.0186. Now, this all you may have been familiar with, but you may or may not be familiar with where does m come from and where does b come from? How do you calculate these guys? Where do they actually come from? And so that's what I want to do, go over with you, because that's part of what we're doing in this lab. So if we scroll down here or take a look at this set of equations, we have here equation for the slope, and so m is our slope. And the equation for m is actually given here in kind of a summarized format. It's actually a rearranged format, but our slope, if we want to calculate slope and we have a data set, we would do it with this formula. Now, there are a couple of things here. N is our number of data points. And I apologize, it's a little hard to draw on this tablet sometimes, and I made a little bit of botch of it, but there you get the number of data points. That's that. Now, when you see any of these types of things like a sigma, that is a summation. So basically, like if we were to take this one by itself, and we were to kind of write that out, where they're typically written in such a way that you're going to sum, going from I equals some value, and typically in our examples it's going to be starting with 1, and you're going to go to the value of whatever n is, and then for this example this would just be the sum of all of the y values. So you'd have y1 plus y2 plus y3, so forth. So this one would be, this particular calculation would be y1 plus y2 and so forth. Now, you'll also have it shown up here as equation for your slope. That's this guy right here. And then we have the error in y values, error in slope values, and error in intercept. And we have basically equations for each of those values as well. So now what I want to do is I want to come down and just kind of talk you through the example that we have given down here in the table. So what we have is a set of x and y data shown here, and there's 4 data points, and the index number, or I, is given here as 1, 2, 3, and 4, and n is equal to 4. And then in this table we also calculate the x square value. So we calculate an x square value for each of the x's and a y square value for each of the y's, and then we calculate an x times y value here. So part of the reason for that is so that we can then come in this table and then sum up those values. So basically, that equation that I drew for you earlier with what the summation for y, well, if we see that equation, we would just plug into that the 20.1, because that's the sum of all of our y values, and that's the way that you would fill this table out. You just add all the y's together to fill it in, and then also how you use these. You just substitute these in place of the summation parts up here. So like here, we have a summation of x squared, and so at that point in the equation, you're going to put in the 32.25. That's the summation of x squared. Okay, so now just to kind of go through the slope and say, you know your n is equal to 4. Oh, and by the way, then all of these values over here are just gotten from the table. So all of our summation values that we've calculated are basically given here in these 5 values. Then you have your average values, which you just calculate from the x and the y. And then you've got, of course, we already talked about that. So down here, to calculate m, you're going to calculate, you go back up to your equation, and you're going to use n, and then you're going to be multiplying times the sum of the x times y. So basically that's where the 62.52 comes from, is right here. And where that 62.52 comes from is basically this part of the equation right there. That is this part of the table. And so you plug that in at that point, and then you can see through this example, you're going to be then subtracting the sum of x times the sum of y. Those two things get multiplied together in this fashion. So you're going to multiply this together and multiply that, and then you subtract those two things. But ultimately, then you use this to calculate the slope. Now, to calculate the y-intercept, you're going to use the slope in that calculation. You're also going to be using the average x and y values, and then you can calculate the y-intercept. Now, you need the slope and the y-intercept, then you'll be using those in these calculations down here. And what I mean by that is you can see the slope is in here, and the y-intercept is in this calculation here. So to get the error in y, you need the slope and the y-intercept. And really, I just wanted to go over, this is the manual method for doing the least squares, and I wanted to go over how to read this table mainly, and how to relate it to those summation values that are shown in the equations above. Now, there is an easier method to do this, and it's known as the computational method, where you just use Excel to do this. And I'll describe that method in a second short video, which you'll see here below. You'll see the link for here just below.